All right, folks, I'm going to go through this word problem, and I just didn't want to take the time to do it in class because we already had kind of long notes, but we have to challenge our minds sometimes, so we're going to do this one. You're designing a marble basin that will hold a fountain for a city park. The basin's sides and bottoms should be 1 foot thick. That's what this is indicating. The outer length should be twice its outer width and outer height. That's what this is indicating. Alrighty, what should the outer dimensions of the basin be if it's supposed to hold 36 cubic feet of water? Okay, so that is asking us for the outer dimensions. So think about what you're supposed to find in the end. The outer dimensions are already given to us. So we're looking for the 2x, the x, and the x because that's our length, width, and height. But in order to solve for those lengths, we obviously have to know what x equals. And in order to do that, we have to use the only piece of information they gave us, which is this interior volume. So when I fill this up with water, I'm going to be able to fill it to a volume of 36 for that inside basin. That is also rectangular in nature, so volume equals length times width times height. But the volume is 36. The length is this full length of 2x, but because this is 1 and this is 1, the part where the water goes, which is right here, is going to be 2x minus 2, because the full length is 2x, and I'm taking away 1 on each end. So minus 1 here, and minus another 1 here. So now I'm at 2x minus 2. My width is going to be this, but again, I'm only looking at the part where the water goes, so I have to subtract a 1 on each side to the left and right. Then my height is a little different. You have to think. This is the full height, which is x, but because the water can go all the way up to the top, I'm going to go ahead and say this is x minus 1, because it's going to still have that floor on it that's 1 inch thick, but it doesn't have a top. So I only take away the 1 time. So now I get to go back to what we did the other day in the beginning of the week, which is multiplying these all out. So I'm going to go ahead and FOIL this. It's going to give me x squared minus 3x plus 2 when I'm done FOILing. And now I still need to multiply that by the 2x minus 2. So if I go through and I multiply everything by 2x, I'm going to get 2x cubed minus 6x squared plus 4x. When I go through and multiply everything by the negative 2, I'm going to get negative 2x squared plus 6x minus 4. So in total, my volume, which is 36, is going to be 2x cubed minus 8x squared plus 10x minus 4. Okay, so that is all kind of what we did earlier in the week. But now what we have to do is kind of add in what we're learning today, which is to find those actual values of x. So the problem is I can't have it equal to 36. I need it equal to 0. So if I want it to be 0, I'm going to have to take away a 36 from both sides. So when I take away 36 from a negative 4, I end up at negative 40. Sorry, I was trying to sort out where I'm going to do my work. I'm going to cram it in up here. So now I'm looking at being able to solve this by factoring. So this up here, this whole part, was really a repetition of what we did earlier in the week in 5-3, multiplying that all out. And now this bottom part is going to be where I start practicing what we're learning in 5-4, which is factoring. And since this is going to have a greatest common factor of 2, I can pull that 2 out in front, because I always got to check first, GCF, otherwise known as greatest common factor. When I pull that out, I end up with x cubed minus 4x squared plus 5x minus 20. That's still all equal to 0. I'm just out of space. and it is 4 terms, so I need to split it. I'm going to keep that 2 hanging around. I'm going to take out of this first section the greatest common factor for those 2. And then for the second half, I'm going to pull out the greatest common factor for these 2. And I'm happy to see that what's in my parentheses is the same, because that's how grouping should work. I still have this 2 kind of hanging out in front. I pull out that common factor from each piece, and then my leftover pieces become another factor, and I'm done. So that was me factoring. Now to solve, I look at each factor to try to decide what makes each one 0. To make a 2 0, not possible, so that doesn't contribute an x value. To make this factor equal 0, x could be 4. Awesome, there's an answer. This one gets tricky because to make this equal 0, x squared would have to equal -5, and so far, foreshadowing, we can't take the square root of a negative, so that one doesn't give me any options. So x equaling 4 is the only realistic option. So after all of this work, I can finally answer this question. The outer dimensions, which are going to be 2x by x by x, knowing that x is 4, this outside dimensions of this basin are going to be 8 by 4 by 4 feet. So my friends, that is sort of the culmination of everything we've done this week. You've got your multiplying to get the volume. Then you've got your factoring and then solving for your zeros in order to get the information that you need. So hopefully that will help you so that when you run across word problems, you kind of have a concept of how to set them up. And we want to challenge our brains and have an honors mentality every once in a while. So this is a good one to really walk yourself through. If you need to watch any parts of the video over again, go for it. See you soon. Bye.